In this video, we will discuss objective questions on milling machine. So the very first question, shaping can be performed more effectively by blank space, milling machine. Horizontal, vertical, can't say anything, none of the mention. The answer is vertical milling machine. So the shaping can be performed more effectively by vertical milling machine. So here you can see this is nothing but the shaper machine and this is your vertical milling machine. They are looking quite similar. In shaper machine you have to fix your single point cutting tool over here and you have to place the object over here. Whereas in vertical milling machine you have to fix a multi-point cutting tool, that is cutter, over here, and this is the table of the milling machine, and you have to fix the workpiece over here. So these machines are quite similar to each other, and that is why shaping can be performed more effectively on the vertical milling machine. Next question, surfacing can be performed more effectively by milling machine. Horizontal, vertical, can't say anything, none of the mention. The answer is vertical milling machine. So the surfacing can be performed more effectively by vertical milling machine. So here you can see the vertical milling machine. Now you can fix the cutter over here. This is the spindle, and here you can fix the cutter. This is the table of the vertical milling machine. You can fix the object over here, and by attaching the cutter over here you can perform surfacing more effectively over this machine. Next question, form cutting can be performed more effectively by milling machine. Horizontal, vertical, can't say anything, none of the mention. The answer is horizontal. So the form cutting can be performed more effectively by horizontal milling machine. Now here you can see the horizontal milling machine. Now what is the difference in between vertical and horizontal milling machine? So as we have already seen in vertical milling machine, so this was your vertical milling machine. Now this is the tool rotation axis. So along this axis, the cutting tool, that is the milling cutter, will move in vertical milling machine. So here the axis is vertical. Now in horizontal milling machine you can fix the cutter over here and the cutter will rotate along this axis, around this axis. Okay, so here the axis of rotation is horizontal and hence it is known as horizontal milling machine. Now form cutting can be performed more effectively by this horizontal milling machine. So here you have to fix the milling cutter and here you have to place the object. The example of form cutting, that is nothing but gear cutting. So while cutting the gear you have to mount the milling cutter over here. This is nothing but the arbor. So you have to mount the cutter over the arbor and you have to place the blank over the table of this machine. Next, slab milling can be performed more effectively by milling machine. That is horizontal, vertical, can't say anything, none of the mention. The answer is horizontal. So here you can see the example of slab milling. This is known as slab milling. So this is the slab and this is your cutter. Now this cutter you have to fix over this horizontal axis. This is the arbor, and on this arbor you have to fix this milling cutter. Okay, and this object, this workpiece, you have to fix over the table. So the slab milling can be performed more effectively on horizontal milling machine. Next question, drilling can be performed more effectively by milling machine. That is horizontal, vertical, can't say anything, none of the mention. The answer is vertical. So here you can see the vertical milling machine. Now this is the spindle of vertical milling machine. Here you can fix the drill bit. So when you fix the drill bit over here, this machine acts as a drilling machine. So the drilling can be performed more effectively by vertical milling machine. Next, which type of machine can be done? Which type of machining can be done by milling machine? Cutting keyways, slot and grooves, gears, all of the mention. The answer is all of the mention. So here you can see this is the milling cutter. Okay, this is a milling cutter. This is also end milling cutter, and this is keyway milling operation. Now this is, here you can cut the keyways as well as grooves, slots with the help of your milling cutters. And here also you can see, here the gears are cut over the blank. So all these operations can be performed over the milling machine, that is cutting keyways, slots, grooves and gears. Next question, which of the following motion does a milling machine has? Vertical motion, crosswise motion, longitudinal motion, all of the mention. The answer is all of the mention. So here you can see the vertical milling machine. Okay, now this is the table of milling machine. This can move left and right, and this can move in and out. So it has a crosswise motion, it has a longitudinal motion, and this cutting tool can move up and down. Okay, so milling machine will have all three motion, that is vertical motion, crosswise motion and longitudinal motion. Next question, upmilling and downmilling are the subtype of blank space milling process. Peripheral milling, face milling, both peripheral milling and face milling, none of the mention. The answer is peripheral milling. So here you can see the upmilling and downmilling. So upmilling and downmilling are nothing but the types of peripheral milling. So here you can see this is an example of upmilling. So in case of upmilling, now this is the rotation of cutter. So here cutter is rotating in clockwise direction, and this is the movement of the workpiece. So in case of upmilling, the cutter and the workpiece, they moves opposite in direction. Now this is an example of downmilling. So this is here also the cutter is moving or rotating clockwise, and the workpiece is moving in this direction. So here the cutter and the workpiece, they are rotating or they are moving in the same direction. So the direction of rotation of cutter and the direction of motion of workpiece is in the same direction in case of downmilling. And the upmilling and downmilling, they are the types of peripheral milling. So here the material is removed peripherally. Okay, here there are teeth on the periphery of the milling cutter, and the material is removed with the help of this peripheral teeth, and hence it is known as peripheral milling. Next question, which of the following milling is known as conventional milling? The answer is upmilling. So upmilling is known as conventional milling. So here you can see upmilling and downmilling, and upmilling is known as conventional milling, where the motion of cutter and the motion of your workpiece is opposite in direction. Next question, which of the following process is known as climb milling? The answer is downmilling. Okay, so here you can see the downmilling. In case of downmilling, this is an example of downmilling. In case of downmilling, the motion of cutter and the motion of the workpiece is in the same direction, and this is also known as downmilling or climb milling. Next question, the thickness of the chip in upmilling is blank space at the beginning of the cut. That is minimum, maximum, zero, none of the mention. The answer is minimum. So the thickness of the chip in upmilling is minimum at the beginning of cut. Now here you can see the example of upmilling and downmilling. So now we are interested in upmilling. So this is an example of upmilling. The second figure, this is an example of upmilling. Here you can see the motion of cutter and the motion of the workpiece is opposite in direction, and this is the chip. Now you can see at the start the thickness of the chip is minimum, and at the end the thickness of the chip is maximum. Okay, and our question was the thickness of the chip in upmilling is minimum at the start and maximum. Okay, so it is minimum at the beginning of cut. So here the answer is minimum. So you can understand from this diagram, this is an example of upmilling, and the chip is represented by blue color. So its thickness at the beginning is less, whereas its thickness at the end is maximum. Next question, the thickness of the chip in upmilling is blank in when the cut terminates. The answer is maximum. So again you can refer this figure. This is an example of upmilling. So when the cut terminates, that is at the end of cut, the thickness of the chip is maximum. Next question, the cutting force is directed blank space, and this tends to lift the work from the fixture in upmilling. Upward, downward, can't see anything, none of the mention. The answer is upward. Now again refer this diagram. This is an example of upmilling. Now cutting force is in upward direction. Now as this cutter rotates in clockwise direction, the cutting force direction is upward in direction. Okay, so the cutting force is directed upward and this tends to lift the work from the fixture. As the cutting force direction is upward in direction, it tries to lift the workpiece from the table. That is why heavy fixtures are required. So the answer is upward. The direction of cutting force is upward. Next question. More depth of cut can be used in blank space milling process. Upmilling, downmilling, can't say anything, none of the mention. The answer is downmilling. Now this is an example of downmilling, the first diagram, where the cutter and the work moves in the same direction. So this is the direction of rotation of cutter and this is the movement of workpiece. So they are in the same direction. So in case of downmilling, we can kept more depth of cut because here the cutting force are in downward direction and that is why we can kept more depth of cut. In case of upmilling, the cutting force is in upward direction. So if we keep more depth of cut, in that case there is a possibility that the workpiece get ejected from the table. Next question. Difficulty is experienced in pouring the coolant just on the cutting edge from where the chip begins. This is the disadvantage of process. Upmilling, downmilling, can't say anything, none of the mention. So the answer is upmilling. So in case of upmilling, we cannot pour the coolant on the cutting edge from where the chip begins. Now this is an example of upmilling. Here this point is nothing but the beginning of chip. I am showing it with the help of my pointer. So this is the point where the chip begins. So the delivery of the coolant is very difficult at this point. So the answer is upmilling. Next question. The work is pulled by the cutter teeth and hence the job may get spoiled or break away. This is the disadvantage of process. Upmilling, downmilling, can't say anything, none of the mention. The answer is downmilling. Okay, the work is pulled by the teeth and hence the job may be spoiled and break away. Now this is the downmilling. Now we are giving more depth of cut and the thickness of the chip at the beginning is also high, and that is why there are chances that the work is pulled by this cutter, as the cutter and the work is moving in the same direction. So there is a possibility that the workpiece get pulled by the cutter in case of downmilling. Next question. As the cutter progresses, the chip accumulates at the cutting zone, spoils the workpiece. This is the disadvantage of the process. That is upmilling, downmilling, can't say anything, none of the mention. Now this is upmilling. Okay, so this is upmilling. Now what happens? We are removing the chips. Okay, now this cutter is moving in this direction, workpiece is moving in this direction. So your chips will get accumulated here. Okay, so as the cutting progresses, right, the chips get accumulated in the cutting zone. This is nothing but the cutting zone, and here the chips get accumulated and this spoils the workpiece surface. So this is the disadvantage of upmilling. Next question. The knee is blank space adjustable on the column in horizontal column and knee type milling machine. Horizontally, vertically, can't say anything, none of the mention. The answer is vertically. Okay, so here you can see the knee type, column and knee type of milling machine. So this is the column and this is the knee. So here you can see this is nothing but the column of the milling machine and this is the knee of milling machine. Now this knee you can adjust vertically. You cannot move this horizontally. You can adjust this knee vertically. So the answer is vertically. Next question. In this horizontal column and knee type machine, cutter rotates about blank space axis. Horizontal, vertical, 45-degree inclined to both plane, none of the mention. The answer is horizontal. Okay, so the cutter rotates about horizontal axis. So this is an example of your column and knee type machine. Now here you can mount your cutter over this arbor. So the cutter rotate about the horizontal axis. So this is nothing but the cutter, and this is mounted over the arbor, and the cutter is rotate about this horizontal axis. Next question. In a universal milling machine, table of the machine may be swiveled about a vertical axis which helps in blank milling. Helical, cam, both helical and cam, none of the mention. So the answer is both helical and cam. So this is an example of universal milling machine. The question is, in universal milling machine, table of the machine may be swiveled about a vertical axis which helps in helical as well as cam milling. So this is the benefit of this universal milling machine. So these are some common objective questions which can be asked in your exam. I have prepared the entire playlist of manufacturing process. You can visit my channel and go to that playlist so that you will get all the objective questions of manufacturing process. Thank you so much for watching my video. Thank you.